Hello, welcome back to Chapter 5, Section 4, where we are talking about completing the square. So now we're going to use that skill of what do I add to my polynomial to make it into a perfect square trinomial. How am I going to use that to solve a quadratic equation? So I printed out the steps for you, and this is, again, I stole this from the book. I'll walk through this, but it's easier if I show you. But I'd like for you to have this nearby someplace when you are working these problems so that you can make sure that you're showing me all these steps. And again, none of this really kind of makes sense until we actually see it. So we'll talk a little bit as we go. The first thing you're going to do is you're going to arrange it in the proper way. You're going to put all of the parts that have x's on the left side. That includes x to the second power and x to the first power. And you're going to put all of the constants, the numbers that are not being multiplied by a variable, you're going to put that over on the other side. Okay? Of course, it'll be easier for me to show you that in a minute, what that means. This second step, this is vitally important. And not only is it going to be important for now, but it's going to be important for the next thing we're going to do when we switch over to functions. In order to complete the square, I have to have x to the second power by itself. And when I say by itself, I mean with no coefficient. So if there is a coefficient, and let me show you a problem that we're going to do. This one is x to the second power all by itself. I have to do something with that, but we'll get to that. This one, though, has a 2. We're going to have to get rid of the 2. So how do we get rid of the 2? We don't just make it disappear. We have to divide every part of the equation on the left side and the right side, every term, by whatever that coefficient is. So I need to get that a away from the whole thing. So away from the x squared is what I'm saying, not the whole thing, because it's going to be divided, everything else is going to be divided by a. Sometimes that's going to be easy, sometimes it's going to make it into a mess, but that's how it rolls. After you get the x to the second power without multiplying by the a, then I'm going to do the completing the square part. All right, and this is a little misleading because this would actually is going to be b divided by a, and then you're going to take that number and divide it again by 2. Okay, so it's not always going to be b divided by 2. I have to say that because I know someone's going to look back at it and go, oh, I just whatever the b is. Remember, you have to do step 2 before you do step 3. But it's okay. Watch what I do in the when I do the problems, and you'll see what I'm saying. Then you're going to change it to a perfect square. So it'll be x plus or minus something in parentheses squared. Take the square roots and solve. All of this is what we did in the first video. Completing the square is what we did in the second video. So now we're going to put the whole thing together. So let's show you an example of what I mean. We'll have this nearby. Step 1. Put all the variable terms on one side, constants on the other. Variables on the left, constants on the right. This variable is in the wrong place. So I have x to the second power equals 27 minus 6x. And the opposite of subtracting 6x is to add positive 6x. So I get x to the second power plus 6x equals 27. Good so far. My second step says divide both sides by whatever a is to make the coefficient 1. Well, my a is already 1. It's the hidden 1. So I don't have to do that step. It's already taken care of. For this problem, when I get to it, I'll have to do something. But this one's okay. Now the next step. Looks like my b is 6. I'm going to take 6 and divide it by 2. Keep that in mind. 6 divided by 2 is 3. Then I'm going to take that 3 and I'm going to square it. That equals 9. And I'm going to add 9 over here to the left. So I get x squared plus 6x plus 9. But here's a problem that happens sometimes. People forget about this next very important part. If I add a number to the left side of an equation, and go back to the first video where I talked about this, this is called the addition property, I have to add that same number to the right side of the equation. So I also have to add 9 here. So make sure you add it to both sides. See that word both? Both sides. Now the next step, I'm going to factor this by recognizing that now I have a perfect square, which happens to be the same one I talked about in the last video. But now I have a perfect square trinomial. This is x plus 3 to the second power. Over here, 27 plus 9 equals 36. And the rest of this problem is what we did in the first example. I'm going to take the square root. Let me write it first. And I'm going to take the square root of the right side. Keep it in mind I'm putting the plus or minus in here because the square root of 36 is positive 6 and negative 6. Again, like I said earlier, I don't have to worry about it over on this side. I just know I got one positive, one negative. This gives me x plus 3 equals plus or minus 6. Please keep in mind that since I know what since I know positive 6 or negative 6, as opposed to like a radical that I won't know exactly, that this I can actually separate. I get x plus 3 equals positive 6, so x equals 3, or x plus 3 equals negative 6, so x equals negative 9. And those are my two solutions. Not x equals negative 3 plus or minus 6. Don't do that. Don't do that. All right, let's pick up the second one here. So I've got the x squared and the 8x on the left side, and I've got the constant on the right side. That's my first thing I got to do. It's already done for me. Now, I have to do something with the 2. I divide every term by 2. That's going to give me x to the second power plus 4x equals 6. Okay, I'm good. So let's check my list. I had that, I did that, now I'm going to complete the square. So I do x to the second power plus 4x plus something equals 6 plus that same thing. 4 divided by 2 equals 2. 2 squared also happens to equal 4. So I'm going to add 4 to both sides. This can be factored into x plus 2 times x plus 2, or x plus 2 squared. 6 plus 4 is 10, and it always will be. Now I'm going to take the square root. Don't forget the plus or minus. And I get x plus 2 equals plus or minus whatever the square root of 10 is. 10 can only be factored into 2 times 5, neither of which is a perfect square. So this is already simplified. So the only thing I can do now is to add negative 2 to both sides, and I get x equals negative 2. Remember, we put it in front, not after the radical, plus or minus the square root of 10. Now, you're probably wondering, why did I leave it like that when over here you split it? That's because I don't know what negative 2 plus square root of 10 is. You cannot add a rational number to a radical. And the problem did not say estimate. If the problem said estimate, then I'd do it on the calculator. Okay, but we're not estimating. Only use this if it says estimate, or if it says something that tells you to estimate, like give your answer to the nearest tenth or nearest hundredth. In this case, we want what we call the exact answer. What is the square root of 10? The exact answer is the square root of 10. That's its name. Okay? You could write it like this. X equals negative 2 plus square root of 10. X equals negative 2 subtract square root of 10. I just want you to remember that it's actually two separate numbers. We look at this and we think of it as like one number. It's not. It's two separate numbers. Two separate values. All right, let's do a couple more here real quick. All right, step one. I need to get that 9x on this side and that negative 2 on the other side. So I'm going to add negative 9x to both sides. And I get x squared subtract 9x subtract 2 equals 0. Now I'm going to add 2 to both sides. And since this is a pre-algebra skill or an early algebra 1 skill, if you did both of these at the same time, that's okay. Either way, I get x squared subtract 9x equals 2. Second step, my coefficient on the x squared is 1, so I don't have to do anything in the second step. Third step, I have to complete the square. I take negative 9, divide by 2, and I square it. Negative 9 divided by 2 is negative 4.5, but again, you do not have to change it to a decimal. So if you see yourself changing something to a decimal when you divide by 2, just remember, I don't have to do that. A negative times a negative is a positive. 9 times 9 is 81. And 2 times 2 equals 4. So I'm going to say x to the second power, subtract 9x, plus 81 over 4 equals 2 plus 81 over 4. Don't panic because of the fractions. You can handle it. This is accelerated math. You can handle fractions. On the left side, I get x subtract this thing right in here. Actually, the minuses are already in there. X subtract 9 over 2, or x plus negative 9 over 2. Squared. On the right side, 2 is the same as 8 over 4. Why did I do that? Because I need a common denominator. I'm going to come back to this in a second. X subtract 9 over 2 squared. This is going to equal 89 over 4. Let's take a square root. Don't forget the plus or minus. And I get x subtract 9 over 2 equals plus or minus the square root of 89 over the square root of 4, which is 2. Now, square root of 89, we got to think about that. It's not a perfect square. 81 is a perfect square, and the next one's 100, so it's between 9 and 10. Can I factor it into a perfect square? Well, it turns out that 89, it's not even. Can I divide by 3? No. Can't divide by any even number. It's not even. 89 divided by 5 doesn't work. 89 divided by 7 doesn't work. I'm going through my primes. 89 divided by 11 doesn't work. 89 divided by 13 doesn't work. So it turns out actually 89 is prime. And that would be very useful information to know. So I'm going to leave it as a square root of 89. The last step, I'm going to add 9 over 2 to both sides. Now, notice that the denominators are the same, so I have a common denominator of 2. I put the 9 in front, and I get 9 plus the square root of 89. Move that up so you can see it. 9 plus the square root of 89 divided by 2. Now, those of you who got kind of far in chapter 9 in the first book might recognize what this kind of looks like. That'll be 2 sections from now. Little tease for what's upcoming. All right, last problem in this video. I have my x squared and my x on the left side, I got my constant on the right side. Step 1's done. Step 2, I have a 3. I need to divide everything by 3. So I got 3x squared divided by 3. Subtract 24x divided by 3 equals 27 divided by 3. Everything gets divided by 3. That gives me x squared, subtract 8x equals 9. Next step, I'm going to complete the square. Over here on the side, negative 8 divided by 2 is negative 4. Negative 4 squared equals positive 16. So I get x squared, subtract 8x, plus 16 equals 9 plus 16. Perfect square trinomial, x subtract 4 squared. On the other side, 9 plus 16, that's nice. That's 25. Why is that nice? Because that's a perfect square. It doesn't have to be a perfect square like we did over here, and for this one I didn't have a perfect square, but when it does equal a perfect square, it just makes the steps a little bit easier. I'm going to take the square root. Don't forget the plus or minus. And I get x subtract 4 equals positive 5 and negative 5. If x subtract 4 equals positive 5, I'm going to add 4 to both sides and get x equals 9. If x subtract 4 equals negative 5, I'm going to add 4 again to both sides, but this time I get negative 1. And my two roots to this equation are 9 and negative 1. I will be doing more examples like this in the guided practice, but before we do that, we have to go to example number 4, and we're going to go back to talking about functions.